Welcome to another video explaining the particle model. Well, hello. Today's video is a video explaining the results of one of the three experiments that I talked about in the previous video. This is the experiment for three resistors in series. The intent to show that the particle model, that predicting shielding will show up in the measurements. So the three possible experiments I mentioned is the three resistor experiment, and I'm going to show the results today, and then there are two other ones which I'll be talking about in later videos. Okay, there are some previous videos you can watch if you haven't watched any videos on circuits of the battery and the resistor, particle-to-particle interactions, and this is the last one I did, which talked about the three experiments briefly, but explained the three resistor experiment in more detail. So you may want to watch that if you haven't done so. Okay, so the standard explanation for a three resistor circuit when you have a 9-volt battery and current flowing through three resistors, in this case 2K, 3K, and 4K, is such that the battery gains 9 volts and the 2K loses 2 volts, then 3K loses 3 volts, the 4K loses 4 volts, and you're back to where you started, and it's a balanced, stable circuit. This is Ohm's law and Kirchhoff's law that explains how you calculate these values. I'm not going to do that, but that's how it's done. Now, the particle model is different in the fact that it explains the operation by saying the battery adds 90 G1 particles to the input. It receives the input, it adds 90, and you get B. If you had 10,000, now you have 10,090. You lose 40 here, lose 30 here, lose 20 there, all equivalent to a voltage drop. And this is what we expect with these three resistors. Well, the test procedure I'm going to do, is performed this way. The first phase of this, the first setup, is to place the three resistors in this specific order. The large one first, then the medium, then a small one. I first measure the resistances of all three, then I connect the 9-volt battery and the resistors in series. I measure the battery voltage and the three resistor voltages, record all that. The second step is to reverse the large and small resistors, leaving the medium one in the middle, and repeat the measurements. And I recorded all of this on a log sheet. And so the first setup is this way. This is an example. I actually didn't use this particular one, but this is a 4K, 3K, and 2K. And the first setup was the large one first, then the medium, then the small. And I measured all the resistance values and voltages. The second setup, I reversed it. I took the 4K, put it up here, put the 2K down here, and did the same procedure all over again and measured it. And of course, this is an experiment in shielding. Shielding is the mechanism in the particle model for causing the voltage drop. The number of G1 particles lost through the resistor is directly equivalent. And this equation shows that to the number lost through the resistor. And so in the experiment, when the 4K is down here, you get the black numbers, and up here, the black shows that there's fewer coming in than coming in at this point. When you reverse them and you put the 2K down here and the 4K up there, you get the red numbers. And you can see that the red numbers indicate that you get more voltage drop when you have the 2K down here, and less when you have the 2K up there. And we're going to expect to measure these differences. with an accurate meter. And there's my 6.5 digit meter, and there's the board that I was using to do it, and here's a picture of it. I was actually doing a 2-hour resistor experiment at the time I took the picture, but here's a large resistor, the medium resistor would go here, and the small one here, then I'll reverse it. There's the battery. And I did the measurements. Here are the results of the measurements with the large resistor, first in the R1 position, which is the first position, and then the voltage drop across it in the R3 in the third position. I expect this number to be larger than that number. I subtract the smaller from the larger, and I'm expecting positive numbers. So I selected 15 different sets of 3 resistors. There's 3 resistors here, another 3 resistors, another 3 resistors. They're all different ratios, hopefully pretty much random. So I'm expecting a positive number, and well, I didn't always get a positive number, and that's to be expected. This is not an easy thing to do, even with a 6.5 digit meter. So C1 and C7, C12 and 13 came out negative, and you might say, well, that's wrong, but I counted those 4 as wrong. 4 out of 4 bad means there's 11 good out of 15, which is 73% correlation. That's pretty good. In terms of statistical measurements where you're down in the mud trying to dig out an answer, that's pretty good. Not 100%, but it's good. Well, there's a couple that came out identical for whatever reason. I remember this happening. This one especially, I'm not sure I remember that one, but there you are. You have 2 of them that are actually 0, or maybe those are wrong. Well, they're positive. And I have a couple others here that were very close to being 0, but not. So you could make the argument that these numbers are not as good as I show, but there's the data. You can play it any way you like. It's pretty good. That's pretty good, the results. Statistically, it could have been worse in my mind. Well, I also did the small resistor. Same set, these were taken at the same time I did the large resistor. The small resistor, when it's in the first position, should be larger than when it's in the last position. And so I put positive down here, but when I recorded all of these measurements, well, it looks like it totally failed. But there's something else going on here. How come so many are negative and only 2 of them are positive? Something else might be going on here. My intuition about what happens with the small resistor may not be correct. So I decided to look into the comparing the measured value, which has nothing to do with the particle model. These are just voltage measurements. There's nothing. The meter doesn't know anything about these calculations. But when I do these calculations, I measure the voltage and I've measured the resistance. I plug them into a spreadsheet and it spits out the answer. And sure enough, most of them are negative. The particle model predicts it was supposed to be negative. My intuition says, no, it should be positive. The way I explained it to you, it should be positive. Turns out to be negative. So what's the reason? Where did my intuition go wrong and the spreadsheet say otherwise? Well, here's what actually happens. This is another picture of the where it shows that this B value, this is B, this is the B value, and this is not a real measured value. This didn't come from the spreadsheet. This did. This came from the spreadsheet, and it turns out that when the 4K resistor is here and the 2K resistor is, I get one value for A, which then makes B different. When I reverse them, I get a different value for A, making B different. Apparently, when the spreadsheet does the calculation to find the right number, it finds it's balanced when it's different. And I told you, no, it's the same. My intuition says, well, it should be the same. Doesn't happen that way. That's not maybe a very clear, direct explanation, but it's what happened. And I'm presenting it as it happened in the spreadsheet. And I'm suggesting that is the reason why I have the wrong answer for the small resistor. So the question is this proof of the particle model? Wow, you've got it. The particle model predicted for the large and small resistor, and you got the results the particle model suggested. To prove that any concept is true, to me, requires direct evidence. These measurements that I did are direct evidence of voltage lost through a resistor. They are not direct evidence of the G1 particle model, the model itself. There could be other explanations. The measurements are only indirect evidence of the particle model. It makes the prediction. The prediction seems right. These measurements only support the possibility that the particle model could be correct, but it's not absolute proof that it is, but it does encourage me to keep going. If there were direct evidence of the G1 particle and that the G1 particle was flowing through the circuit and that it interacted as described, then maybe it would be proof. My next two videos are going to explain first this one and then this one. And it's going to be a while for the results, and I don't know if I'll ever get the results of this one, but I'm going to explain them to you in the next two videos. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.